going to conferences all the time is the main driver for progress in your skill set and also your relationship, and basically any professional can become a better professional by attending conferences.
It's not the standard, okay? It's a movie theater, but the visual is great and the sound is great, and I've seen a lot of room and space, and I think it's organized well.
Seeing all the people here today and they're excited about stuff, you can see the energy and the desire to learn and do new things.
And I was positively surprised about the depth, the technical depth of the sessions, and how that makes the tester part of the team.
I think developers do benefit from coming to QA conferences, just the same as testers can benefit from going to dev conferences. You've got to have a broad understanding of what's going on.
It's really inclusive. I would say it's super diverse. People are really, really open and friendly, and it's really organized.
Conferences are well worthwhile just for the ideas that they spark in people. When people come back to the office, they're full of ideas and they're all energized up.
Hello there, my name is Paul Gizzaffi, and I'm a Principal Automation Architect at Magenic. I live in the Dallas-Fort Worth area of Texas in the United States, and my talk is on applying basic software practices to our automation development. Automation development at its core really is software development, and we need to treat it as such. So applying these basic principles when appropriate and where appropriate will help us reduce maintenance, increase the future-proofing of our automation, and increase the value over time. Hope to see you at my talk. All right, good morning, good afternoon, and good evening, everyone. Thank you for spending a little bit of time with me today. My name is Paul Gizzaffi, and we're going to be talking a little about automation today and stacking your deck. I'm a Principal Automation Architect at Magenic, and I've spent my career focused on automation. I'm an advisor to two different organizations, STPCon and the Advanced Research Center for Software Testing and Quality Assurance at the University of Texas at Dallas. And also, if you want to ping me and talk about which Running Wild or which Ozzy Osbourne record is best, let me know. And if you do want to contact me outside of this particular forum, here is my contact information. And the link at the bottom there is where I do blog from time to time. So I'm not much of an agenda or overview guy, so let's jump right on in. So you're starting an automation initiative and you think you need to write your own framework? Well, don't. That's the simple answer, or at least don't start there. And the reason I say that is for most of us, building an automation framework, an automation stack, an automation base, it's not our core competency. It's not what we're doing. So it's what we call an opportunity cost. We're spending money or spending time, or both really, building something that is not actually the product we're delivering. So it might not be worth doing it. There are so many automation helpers, frameworks, libraries, different types of things out there, both from vendors and from open source, that you may find something that meets some, most, or even all of your needs without you having to develop anything. But for the purposes of the rest of this talk, we're going to pretend that that is not true. We're going to pretend that you do, for one reason or another, decide that you do need to write your own automation libraries. So let's help you do that. So the name of this talk is called Stacking the Automation Deck. And when you're playing cards, stacking the deck really means cheating. It means arranging the cards in the deck so that they come out in your favor, so that you can win. And that's what we want to do here, is we want to stack the deck and talk about your automation stack. And when we talk about stacks and we talk about automation, one of the main things that we do need to remember is automation is software development. We have to treat it that way. We have to do all the things we would normally do for software development. Plan it, allow for debugging, documentation, all those normal things. I could go on for an hour about just that, but as Alton Brown would say, that's a different show. So let's start with this. What's a framework? Well, Merriam-Webster says that a framework is a skeletal, open work, or structural frame. And I once read on Twitter, I believe it was, that you don't call a framework calls you. So a lot of times what we're calling a framework is not really a framework. It's something else. It's a set of libraries. So let's start using this and building this and thinking about these types of things in terms of what they really are. So when I talk about a stack and stacking the deck and your automation stack, what is a stack? So again, Merriam-Webster, our friendly neighborhood dictionary, says a stack is an orderly pile or heap. And when we talk about stack in this context for this particular talk, it's not the classic computer science definition of stack, which would be a last in, first out kind of data structure. And it's certainly not the computer science definition of heap either. No, what we're really talking about is a stack, like stack of cards, or here we have a kind of a disorderly stack of blocks, and then here we have a very, very orderly stack of golf balls. So stacks come in different flavors and different types, and in different situations, you may want an orderly one or maybe a not so orderly one. So why do I talk about using a stack? Well, a stack allows us to use some basic computer science idioms, some ways of doing things that are very valuable, very powerful, and help us reduce the cost of maintenance over time with our automation engagement. And really over time, that's where most of the money gets spent if we're not really careful in how we develop our automation. So the first computer science idiom that a stack will allow us is encapsulation. If you're not familiar with encapsulation, it's the hiding of implementation and or data details. So basically, you would be hiding maybe which tool you're using, which data structure you're using, how it's structured, and by building an encapsulation around your actual call, say to your tool or to your data structures, it allows you to add additional features that the base tool doesn't have, and it allows you to change your implementation without affecting the users of the encapsulation. So it can definitely reduce your maintenance costs there. Going hand in hand with encapsulation is the concept of abstraction. And abstraction conceptually is making the concrete more general. And here's an example of an abstraction is if we take the concrete like the different suits of a card deck, the spades, the hearts, the diamonds, and the clubs, there are certain things about those that are common. And we can abstract those things into sort of a base class, a base definition of something called a card. A card has two sides, it has a suit, it has a number, it's got a pattern on it. All of those generic and conceptual items can be pulled into a common space, and then the individuals can implement the concrete aspects of those. And by going with an encapsulation and an abstraction approach, we can build layers. And sometimes our layers, as I mentioned before, can be very orderly, sort of like the cake there, or perhaps they're a little more disorderly, and perhaps they leak a little bit, intentionally or unintentionally, sort of like the M&Ms coming out of that particular cake there. It reminds me I haven't eaten breakfast yet, so I'm hungry. Anyway, this increases our reusability, and our reusability can, over time, help us reduce our effort on maintenance. So that's why we would use a stack. So why not a framework? Well, if we're looking more closely at the definition of framework, what a framework calls you, a lot of frameworks out there already. I started my career back before there were a lot of these types of frameworks available. Perhaps before any of these that I listed here were available. And we had to build our own framework. We had to build our own assertion context. We had to build our own test runner. Those things are sort of commodities today. You can go and download them, or you can buy them, or you can interwork them together. There are all sorts of ways that we can do this and not have to build the commodity part of the stack, which is the test runner and the assertions. So conceptually, when I talk about a stack for automation, what am I talking about? So several layers here in this stack. At the bottom is the raw tool. This is the real tool that you're using, be it Selenium, Test Complete, Water. You pick it. You can come up with a bunch of different tools that you could put there. Above that, we talked a little about encapsulation and abstraction. So here is where we would put our future proofing and help. And we're going to see some examples of this coming. But for example, in a UI framework, a lot of times we spend activities around waiting, right? Because when you use a user interface, particularly a website, there's a lot of clicking and waiting, typing and waiting, looking at something and then waiting for something else to happen. And waiting in some of the tools can be a little bit tedious from a programming standpoint and repetitive. So we can bury that, we can bake that into the lower levels of abstraction, of encapsulation, so that it is easier to use and it's future proof, such that if there is a change in the way some of that behavior works, we can change the encapsulation and minimally or not at all affect the higher layers in the stack. So the action layer, these are domain specific actions. If you think about generically finding a UI element, and a lot of the examples I'll talk about here are sort of UI based because more people can grok that and understand that, because most people have used some sort of UI. But these approaches apply outside of UI automation as well, into messaging, into APIs, into databases, into anything where you want to add some future proofing and some layers of abstraction and encapsulation. So here, domain-specific actions might be find the login link or type into the password field. And if we think about actions as rather atomic, locate and then perform some sort of action on the thing we located, behaviors would be reusable groups of actions. So clicking the login link would be an action. Log me in, which would perform all of the login functions for you, would be a behavior. And then on the top, we have the actual script that is driving the testing, sort of the executable contract between what we think we want the system to do and what the system's actually doing. And then up the side here, because it can cut through most, if not all, of the layers, we have a set of utilities that are reusable. What kinds of things go in the utilities? Perhaps XML file readers or database access or access to email, different things that you might want to interact with, but not directly part of the stack because they do need to span larger areas of the stack. Pardon me for a second. Sorry about that. So let's go on to a conceptual example. Let's say we have a very large number of test scripts. And for 400 of those test scripts, in order to continue the rest of the testing, we need to log in first. So here we would log in with an ID and a password. And the first thing we do when we log in is we click the login link. Then we fill in the ID field and the password field, click the login button. And then how do we know we're logged in? Well, we can see a log out link. So if we find that there's a log out link, then we say, cool, we've been logged in. So how do we find this login link? Well, we find it by element ID. So in this particular case, the ID is called foo. Great. So it seems kind of overwrought, perhaps a little too much effort to go through and build these layers and test and maintain these layers just to log in, right? But wait a minute, something changed. The developers changed something, either on purpose, necessarily, or unnecessarily. The ID changed, and we talked to the developers and said, hey, look, we've broken up 400 automation scripts. We need you to change that ID back. And the response is, we can't for reason A, B, or C. That may be a good reason or maybe a bad reason, but nonetheless, now we have to change this ID. Had we hard-coded that ID into all of our test scripts, then we would have to go to 400 test scripts and update that ID. Sure, perhaps we could do some find and replace across the file using awk instead, or grep, or whatever tool set you would use to perform that activity, or maybe just bring them into an IDE and change all the instances. And with something like foo to bar, that might be easy, but in other cases it might not be so easy. So what do? Well, fortunately, we applied an encapsulation principle here and built our layers. So we change it in one spot, the one red circled spot. We don't change anything in the behaviors. We don't change anything in the scripts. And the scripts, remember, are the most important thing that we don't want to change, because they are that executable contract between what we think we want the application to do and what it's actually doing. So cool. We kind of understand now why we have this actions layer. What's up with this behavior layer? Uh-oh, another change has been made. Product ownership came in and said, hey, we have another feature, and now we don't know if we're logged in just by looking for a log out link. We also need to find this profile link. So the combination of the profile link and the log out link tells us, yes, if we see both of those, then we're completely logged into the system. Again, had we put that information, had we put those steps directly into the scripts, we'd have to go to 400 places and make those changes. Doing this with an IDE or grep and awk instead might be a little more difficult, because you have to have a little more context about where all these places would be. So we change it in one spot. We add the assertion for that particular action in our behavior layer for login. So what we did was we changed the behavior, but we did not structurally change anything that existed already. So in the actions, we would have to add another action, that is to find the profile link, but we don't have to change any of the ones that are there. So no changes here, and no changes to our scripts, to our executable contract. So applied judiciously, this can absolutely lead to reduced maintenance. Now let's go to some more concrete examples. So these examples are taken from a framework that we developed here at Magenic. It's called Max. There's a Java version also called JMax, and you can find those out in GitHub. They're completely open source, MIT licensed, I believe, so it's pretty permissive. Use them to your heart's content, or just look at them and borrow good ideas from them. Or should I say appropriate ideas, because a good idea for somebody might not be a great idea for someone else. So looking at this abstraction and encapsulation layer, so we have a method here that's called wait for contains text. So wait for an element to contain text. And then what we do is we wait until the element does contain expected text. And that is another method call further down in the stack that actually performs the activity of looking for that element with that text. The waiting is handled by the higher method, but the actual looking for the text is lower. What this does is, if there's some sort of change in the way, and this is Selenium, the Selenium handles either waiting or finding with specific text, then that change is isolated to one spot, and we don't have to go through multiple places in the stack, or even worse, multiple places in the test scripts to make those changes. Again, helping us increase maintainability and reduce the effort we spend on maintenance and support. So going one layer up in the stack, we go to the action layer. So here we see we have 3 different actions. We have the username input, the password input, and the login button, any of which we could ask if they assert, we could type into or click, all sorts of different types of actions to perform on these so-called finders or locators. And then we have the behaviors layer. And you'll see at the behaviors layer, we make use of the action layer. We look for the username input and we send the keys, and the password input, and we send keys there. Then in the script itself, we actually call enter credentials, which is what we saw in the previous slide, that enters our credentials. So what we're doing is at the script, we're calling one layer down into behaviors. But our abstraction is intentionally, our abstraction and encapsulation are intentionally leaky, which means from a higher layer, you can call into more layers than just the one below. This is intentional, but it is risky from an implementation standpoint. So here, not only do we call the behavior method, the behavior layer, enter credentials, we also call the action layer, which is 2 layers below the script, into the login button. This is incredibly powerful. It allows us to do more at the script layer, but the more we skip layers, the more tied we become to lower layers and the more risky we are, or the more brittle we become with respect to um, to changes in the lower layers. So that if there were a change in login button, enter credentials would automatically get that change, but here we would have to go and actually update any scripts that call login button directly. So it's powerful, but we have to use it appropriately and very carefully so that we don't accidentally increase our maintenance load just by some accidental use of, or some careless use of, lower layer functions. So what's this look like in the real world? And the telecom, I worked for a telecom company for a long time, and here's where the sort of the seed of this concept of these layers came from. So again, here's the actual conceptual layers that we've seen already. How did this apply in the telecom company? Well, we had a proprietary set of APIs that drove a proprietary piece of hardware. The encapsulation layer there was called the test head, and it was a piece that you could think of it really as a big, giant, fat device driver that knew how to speak to the proprietary APIs on one side and then to our test system on the other side. We then had the test services, which would largely be equivalent to the action layer. In our case, it would be send this particular message, or it would be go off hook or dial these digits. Above that, we had the behaviors, and what I would use the term DSL. We had a few different ones based on the different organizations we were working with, and it would do things like, say, originate call. And originate call would largely be go off hook, dial number, or wait for dial tone, and then dial digits would be a call origination. And then the script itself, in here, it was really a program. It was C++ because that was the language we were using at the time. Eventually, we evolved this, and it became Java. So we had an advantage here with what went in what layer, because necessarily, because of the architecture, we ran certain pieces of the tool and the platform on different machines. So the test head and the proprietary APIs ran in some lab for some network office location, and would talk directly to the piece of hardware. Then across the corporate network, we ran the rest of the system. So the test scripts, the DSLs, and the test services, or the behavior and the API and the action, would run over on a shared workstation and communicate with the back end across the corporate network. Coming into something that's a little more digestible for most people, I did work in an e-commerce organization. Again, here is our conceptual stack. Excuse me. And when we started, WebDriver was not quite where I needed it to be yet. It was still under construction. It was doing some things very well, but we needed Safari, and there were a few other features that we needed that were not there yet. So we went with something for the short term called Webspec. It was also called Wattage, or Web Automation Testing in Java. So what I did was I sort of accidentally, because I didn't really have a good grasp of the conceptual nature of this stack yet. I kind of knew some of the implementation of it because I'd done it at the telecom company, but I didn't realize the value in splitting the actions and the encapsulations at the time. So we built sort of a combined actions and abstractions layer called Finders. Then we had a similar DSL, but instead of doing call origination, it was things like empty my cart or log me in. And then we had a script which was Ruby, more specifically JRuby, because we were taking advantage of the Java version of Webspec, and JRuby allows you to call both Ruby and Java functions from the same script. And then it was time to move. It was time to move on to Selenium, because Selenium was finally where we needed it to be. It had some capabilities such as Chrome that Webspec did not have, and we needed to have that sooner than later. So we started making our migration. Again, we had our conceptual stack, but I had blended the encapsulation abstraction layer with the action layers. So part of the activity here was to build what we call the Selenium wrapper. And I was fortunate that the Webspec API and the Selenium API, both of them were sufficiently accessible, for lack of a better term, that I was able to basically reproduce the Webspec API with a Selenium implementation. It was a lot of work. It really was a lot of work, and that was a mistake I wish I had not made at the time. But I was able to keep the finders by and large. I think there were a handful of finders we had to change. The behaviors didn't have to change at all, because again, what we changed was the structure. We changed the lower level tool. We didn't change any of the behavior, and we didn't change any of the scripts either. Okay, that's a little bit of a lie. We didn't change any of the business logic part of the script. Each script had to change one line in how it created the browser, but all of the rest of the logic, the checking of how the application and the website actually worked, none of that changed. So in one way, we got kind of lucky because Selenium and Webspec, while their interfaces are wildly different, each was flexible enough that I was able to implement one with the other. So moving from there, I went to a software as a service company. Again, conceptual stack, and you'll start to see a pattern emerge here. And this is, it was late in my e-com world there, before moving on to the SaaS company, that I really started to define what this stack, the conceptual stack, looked like. Because we look here, we see the Selenium wrapper, which looks very much like what we had at the e-com. With the page objects, which were sort of our finders equivalent, because we were following a lot stricter version of the page object model here. And here we had two different sets of behaviors and scripts. There was a need for behavior-driven development by some of the teams, so we put SpecFlow on top, but we also had a model very similar to what we had both at the excuse me, at the telecom company and the e-com company, which was this notion of a DSL and the C#. And again, I'm abusing this term DSL here because it wasn't so much a separate compiled or interpreted language like Gherkin would be. It was still code. It was directly in code, but it was named a lot more English-like than what some of the other code you might normally see. And then the company I work with now, Magenic, we're a consulting company, and what we found was over time we were building the same thing over and over for a lot of our clients. So we took some of our non-client, non-billing time and built something more generic, more reusable, and then we put it out for public consumption out in GitHub. So here we have the raw tools. We have Selenium, we have web services, we have Appium, we have some database access and email access there as well. But those three at the bottom that you see here are the ones that most of our clients use most of the time. And again, we have a wrapper layer. So we wrap Selenium, we wrap the web services, we wrap Appium. Why do we do this? In case there are changes that we need to absorb and we don't want to impact our or our clients' test scripts. And we can add additional help, additional items to make the programming, to make the maintenance more digestible and the learning curve and the learning ramp a lot less steep. So here at the action layer, we call it models because for Selenium, it's page models. For the web services, it's more like object models or message models. And then for Appium, it's more like widget models. And we still support SpecFlow and DSLs. And here we have both C# and Java. So we have a C# version and a Java version. So into each life some rain must fall. These layers and encapsulation, all this is great. It's great for support. It's great for maintenance. It can be great for readability. It can be a challenge when we want to debug because we do have to step through these layers of indirection. We have to go from the script to the behavior, possibly to another behavior, to another action. And then if it's something where the action seems to not be doing the right thing, perhaps we have to go down into the actual implementation of the abstraction. So it can get icky. Higher layers can hide lower layers details if we're not careful. It is very easy to accidentally or purposely and not intentionally, or sort of intentionally, but not with the desired result, eat some of the logging and some of the error messaging that might come from a lower layer. So what happens is each layer needs to log what they find, what they do in a jargon, in a domain context that is understandable to who cares about that layer. And we're going to see an example of this in a second. I know that's a little bit hard to digest, especially over video here. And making them context sensitive, right? Like I said, so the in a domain language, in a jargon that is understandable to who cares about that layer. So what am I talking about? Let's pretend I'm back at the ecom site and I just want to buy a CD. And I try to add it to the cart and something happened. It just didn't get added to the cart. So in my test script for that, that would fail. And what would I want to see in my error logs here? Well, the first thing I want to see is, hey, I failed to add the CD to the cart. Okay, that's great. But what happened? Why couldn't I add the CD to the cart? Well, I couldn't find the add to cart button. I tried to click the add to cart button and I couldn't find it, couldn't locate it. Why couldn't I locate it? Well, specifically, I couldn't find that particular web element. And as you can see, we get more granular as we go down in the stack. And it's the vocabulary, the jargon starts to change a little bit the lower we go. And at some point, the writer of the test case, the test script, may not care as we go farther and farther down the script. Perhaps they don't know that ID flum NLP with that number string there is the right one or it's not the right one. But they certainly could say, hey, I couldn't find the add to cart button. So combining these layers of logging that match your layers in your stack with appropriate vocabulary and a screenshot, often that is enough to do your debugging, or at least to start your debugging, because you can look at the screenshot and say, hey, is that button there or is it not? If the button's not there, we stop. Look, the button's not there. Let's open an issue. Let's talk to a developer, or whatever your process is. If the button is there, then we start a different kind of evaluation. Is the ID incorrect? Is there a timing issue? Is the script behavior wrong? Are we doing things in wrong order? But we'll go down a different path because we have this particular specific logging at each level. We can do that without having to rerun, without having to do a whole lot of like archaeology into our code and into our logging. So another thing that stacks give us that frameworks do not is the ability to use this software outside of a test script. If our stack is married, if it is bound to a particular framework, or it is a framework itself, then you have to use that framework to a large extent the way that the framework wants you to use it. If we take our software, our stack, and build it as a stack where it is independent of the framework, but still usable in the framework, we can do different things with it. So for example, at the Ecom company, we reused the Selenium wrapper, and Finder layers and built something called an order pumper. Long story short, we needed to pump orders into the system, and it just took a while for humans to do all that because of all the clicking and the waiting. So we built this order pumper to run through, put all the orders in overnight, and then when the testers came in the morning, they had a list of order numbers that they just had to go through and verify that everything was in its right place. So we took the brunt of this effort, right? The worst part of this, the most expensive part, let the machines do it. And we let the machines do it overnight so that the testers weren't really waiting on it. And when they came in, they had some information that they can go and evaluate. And if the information didn't jive with what they expected, it was actionable. We also built something called a random link clicker, and the random link clicker does that. It randomly clicks links. It is based on something called high volume automated testing. So you can go and look up high volume automated testing, or HIVAT, HIVAT. But the idea here is to look for valid scenarios and valid paths through the system that may not be intuitive. And so I would like you to think I'm a genius, that I invented all this on my own, or that myself and a handful of other people invented this notion of this stack, but that's not really true. Unbeknownst to me at the time, there's this book called Experiences of Test Automation, and there's a stack in there that very much mirrors conceptually the implementation that I've evolved and people I've worked with have evolved over time. And this is a wonderful book by Dorothy Graham and Matt Fuster. I highly recommend it. So there is something to be aware of here. There's another kind of stack we have to be very, very cognizant of not building, and that is a house of cards where one little breeze, one movement of a card can make the whole thing collapse. It is very easy to build a brittle stack. So how do we avoid that? In stewardship, someone looking after the stack, or some group of people looking after the stack, deciding what goes in which layer. Because it matters and it doesn't. It matters that it's consistent and appropriate for you for what you're building. So it doesn't matter that it doesn't match mine. It matters that it fits what you need for it to do. And it matters that someone is overseeing and helping make these decisions, and including programmatic checks. So just general guidance. The bottom two layers here are general. They should be able to be used across various projects, various organizations. That's what the Max framework gives you, the one that's developed by Magenic. Above that, the general layers are facilitating the creation of the higher level layers. They're more domain specific. And It's less granular as you grow up the stack and more granular as you go down. And be careful. The higher layers can call the lower layers if you implement your stack to allow that. But there has to be judicious access of that, because if you don't, if you carelessly or without sufficient forethought use the lower layers, then you're going to inadvertently tie yourself to the lower layers and be more susceptible to changes at the lower layers. So quickly, stacks are portable. You can use them in frameworks and non-traditional automation that we call automation assist, like the order pumper and the random link clicker. Use the software development idioms. This is software, so use the appropriate idioms. Appropriate logging and error messages are critical, otherwise you won't know what your system's doing and you won't be able to trust it. And use appropriate stewardship to get things done. And now I'm going to take a few questions because I do have a few minutes left. Let me click over to this. To the live questions. Let's see. Okay, first question. I see that modern tools like Cypress have their own architecture that are somehow maintain this stack, but you couple with the raw tool. What do you think? So it's not so much about the specific tool. If the tool that you, I have a separate talk on tool selection as well. If the tool that you, the tool that is most appropriate for you gives you everything you need with your stack and everything else, then that's fine. But realize you are now marrying that tool. It is going to be very difficult for you to migrate away from that tool if its terms of use become untenable, or if there's a feature in there that you don't want, or something. So it's just one of those sort of considerations that you have to think about and understand. How much are you binding yourself to that tool? And hello, Lauren. Great to hear from you. I hope you're enjoying this. And thank you for the comment about the logging in each layer as well. Let's see, what about ownership? From your experience, who maintains each one of the layers in the stack? That's a great question. So the stewardship should help that, but not so much from an ownership, but from a direction. Generally, the ownership or the governance would be the domain-specific teams should own the domain-specific parts. So if you're looking at the script, the DSL, and the actions, those would belong to something domain specific. So if you have a team building your loyalty website, those layers would be different than the ones building your general e-com website, and they would be kept separately. But the shared parts of the framework, the abstraction, and potentially even the raw tools, perhaps there is a single group maintaining that and building that out so it's shared. Perhaps it is your company and your organizations are disparate enough that it doesn't make sense to have one tool. So each organization may have its own as well. And I hate to keep saying this, and so many of the answers to questions these days are it depends, because it really does depend. Your automation implementation and selection really has to match with your strategy, with your audience and the people that are interacting and consuming your automation, and with your environment. So I'm not testing the same thing that you're testing, and somebody else is not testing the same thing that either of us are testing, and we have different types of people with different sets of experiences doing the work. So the automation is almost necessarily different, certainly at the higher layers, than for each other. Let's see, how do you organize the tests? So what we typically have been doing with our clients lately is the tests and the domain specific parts, so the scripts, tests, the actions and the behaviors all live with the application that they are testing. Then the common layers They belong to, most of the time our clients are good fits for one of the versions of the Max framework. So that gets supplied either through NuGet if you're coming from the .NET side, or through Maven if you're coming from the Java side. So it is sort of inorganically separated that way, simply because you're not maintaining and building that part, those lower layer parts. So would I keep each stack in a different directory? If they are separate stacks, yes. Kind of like we talked about, if we've got disparate websites like loyalty versus ecom, certainly the higher layers would be kept in different directories, repos, what have you. But the common parts would be kept separately from that, so they could be truly common across the organizations. Did you wrap as well how these tools are called to test? That is, how Selenium is called to run the test in your framework. I'm not sure I understand that question, but we do have some linkages into the test runners, but they are soft linkages such that they are swappable. For example, Max will run both on InUnit and on MS Test. So there's some knowledge in the back end, in the lower layers of the framework, to know that, oh, I'm running in this framework or this other framework. But other than that, all the other pieces are common, and it really more has to do with setup, teardown, and logging. And I think I am at time now.